And we've also been developing a lot of technology that is equipped onto the vehicle, and this really sets us apart from the competition. The competition, in the main, is taking a traditional electric baggage tug and is converting it into an autonomous driving vehicle. That is just a towing vehicle. It cannot carry its own load. It's a towing A to B, B to A vehicle, and it also can't get up to the aircraft to load and unload its own containers, and it can't get into the baggage hall and load and unload its containers. So we are attempting to do a complete end-to-end, no person involved operation, whereas the competitors are still doing towing transportation. And we've got various bits of technology, dynamic alignment that we've developed that enables us to navigate on the stand. We detect every single piece of GSE equipment on the stand, where it's positioned, and in fact, even if it's moving or not moving, which enables us to navigate whether we're going forwards, backwards, or sideways, or at an angle, to actually go around those pieces of equipment to do our mission. We have aircraft precise location. So when an aircraft lands, it looks like it's in the same location, but it's not. And every time you go onto the stand, the aircraft is not positioned in the same precise location. So we have to scan the aircraft and accurately get a dimension to enable us to dock directly to the piece of equipment that is touching the aircraft. We're the only company in the world that has insurance to enable us to dock directly with a piece of aircraft equipment. And that has taken quite considerable time for us to get to that position, to convince authorities, insurance companies, and to build safety cases that people can ratify and understand. The third thing is we have spent a long time weather hardening our vehicle. And what that means is that traditionally autonomous vehicles are not very good in heavy rain or heavy snow. And that's not very much use when you're in Singapore and you've got a big downpour, or you're in Canada or America and you're operating in snow. So we spent a lot of time, both mechanically, but more importantly on software algorithms, to enable us to drive in very hard conditions. And today we can operate fully in rain up to 50 millimeters per hour and snow up to 10 millimeters per hour. And if you were to see those levels, they are incredibly difficult to operate in. But we've managed to do this and prove to our customers that this is possible. And amongst all the many pieces of technical things that I could tell you, these are just a snapshot, but the final one is we have now developed an automated way to cross a live taxiway. So normally if a vehicle wants to cross a taxiway, they talk directly with the control tower. But of course, our vehicles autonomously, they don't have anybody on board. So how do you get a computer to do that and understand where it is, how it sees the aircraft, are the aircraft moving or not? And we've got some really, really good technology in the vehicles now and in our systems that enable us to do that. And those are subject to patents. And we've developed that and proved it out in operations at Cincinnati Airport. So all of these, what sets us apart technology is underpinned by all of the other technology that we've built up for many years now. And this is all coming together, including being able to have our Auto Connect platform with a complete blockchain distributed identity per vehicle, which means it's very hard, almost impossible, to crack our vehicles on our network.